In 1986, the Challenger space shuttle exploded 73 seconds after takeoff. The night before the flight took off, one of the lead engineers at NASA told his wife the shuttle would blow up. So how did he know, and why did it take off anyway? The shuttle took off at an exciting time in history. We were deep into the space race, and this was going to be a historic flight that included a teacher who would do live demonstrations from space for students across the country. The launch was broadcast on national television, and much of the country watched in horror as the shuttle exploded in real time. It turns out what happened was that multiple rubber O-rings, named for their round shape, broke apart on takeoff. This caused the fuel segments to rupture and explode the shuttle.
T-minus 15 seconds. T-minus 10, 9, 8, 7, 6. We have main engine start. 4, 3, 2, 1, and liftoff. Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
To my knowledge, I was the only one that called it in. No, it's gonna blow.
Program confirmed.
And they tried to launch it, even with me saying, don't do it. It took off like any other rocket, you know. Once it gets started, it's started.
Challenger, go with throttle up. Challenger, go with throttle up. Flight Fido, go ahead. RSO reports.
So how did the engineer know this would happen? Well, NASA does testing on all parts of their shuttles before they launch them with people in them. You can see here the results of their testing on the O-rings to check for failures at these critical joints. They built in redundancies to their system, so a failure of one or two of these joints would not cause any kind of catastrophic problem. Space shuttles were launched from Cape Canaveral in Florida, so you can see they did much of their testing there in the warm weather that area typically experiences. However, on the day of the Challenger launch, there was an unusual cold snap, and the weather was expected to be 29 degrees at takeoff. Using their testing data, NASA leadership created a regression line and found that there was no relationship between temperature and the number of incidents with the joints. Therefore, they said that a takeoff in colder weather would not cause any problems. But cold weather does cause problems. If you've ever seen what happens to rubber when it freezes, it becomes very brittle. At launch, multiple O-rings failed, causing the explosion. In a later analysis of what went wrong, it became clear that the data they used to clear the takeoff was flawed. The engineer who predicted the shuttle explosion knew this and brought it to the attention of his supervisors, but they ultimately ignored him. It turns out when they created their regression model, they excluded much of the data they collected from their testing. Engineers had done many more tests, which resulted in no failures of the O-rings at all. They ignored this data as not important and restricted the range of the data in their analysis to only include tests that had one or more failures. By adding in all the test results, you can see there is a clear negative trend. The people that cleared the launch made two critical errors. First, they restricted the range of their data in two ways. They ignored important information from tests with 0 incidents, and they never conducted the test in weather cooler than 54 degrees. Restricting the range of their tests means that they could not accurately make predictions about events outside of this range. Additionally, they use their data to extrapolate, which is using our model to make predictions outside the range of what you can accurately use the model for. The rings were never tested in freezing weather. Making assumptions about how they would perform in those conditions was not something they could accurately do. As we have learned throughout this course, statistics can be a useful and life-saving tool in many fields. But remember, we need to apply the critical thinking skills we have developed this semester to what we find and pay attention to what statistics can and can't tell us about our world.